Today we're going to talk about zero and negative exponents. So just like the exponent rules we've learned before, we're going to look at some patterns and see if we can identify the patterns that explain why the exponent rules are what they are. So we're going to read the directions. We're going to fill out the chart on the left. So if you look at the directions, it says look at the left column of the table, then describe the pattern in the exponents as you look from the top of the table to the bottom of the table. So on the right-hand side over here, we're going to fill this out. 2 to the fourth power, if you use your calculator, 2 to the fourth means 2 times 2 times 2 times 2. When you do that, you're going to get the number 16. 2 to the third power is 2 times 2 times 2, which is going to be 8. 2 times 2 squared is 2 times 2, which is 4. 2 to the first power is 2. So then what we're going to do is we're going to start to fill this in. So notice how the exponents go from 4 to 3 to 2 to 1. The next one would be 0. And then 2 to the negative first, 2 to the negative second, 2 to the negative third. Now, what we're learning today is 0 and negative exponents. Also look at the pattern from the top of the chart to the bottom of the chart. To get from 16 to 8, you could subtract 8, but you could also divide by 2. If you look from 8 to 4, notice you could subtract 4, but you could also divide by 2. So notice up here, 16 to 8, divide by 2. 8 to 4, divide by 2. 4 to 2, divide by 2. 2 to the next one would be divide by 2. 2 divided by 2 is 1. Then you take the next one, and you go 1 divided by 2, which would be 1/2. And then 1/2 divided by 2, well, if you cut 1/2 in halves, you would get 1/4, and then you would get 1/8. Now the calculator will do this for you. If you type 2 to the 0 in, you're going to get 1. 2 to the negative first, you're going to get 1/2. 2 to the negative second, you're going to get 1/4. 2 to the negative third, you're going to get 1/8. It says, based on your observation above, continue the pattern on the left, which we did. Observe the numbers in the right column of the pattern from the top to describe the pattern. What are we doing? We're dividing by 2. Okay. This is based on your observation of problem 4. Continue the pattern for the right column of the table, writing your answers in fraction form when necessary. So there it is. Okay. So let's look at the next one. Same process. 3 to the fourth is 3 times 3 times 3 times 3, which is going to be 81. Again, the calculator will do that for you. 3 to the third, 27. 3 to the second is 9. 3 to the first is 3. Dividing by 3 each time will get you the next number. 81 divided by 3 is 27. 27 divided by 3 is 9. 9 divided by 3 is 3. So then what do I get if I have 3 to the 0 power? Well, 3 divided by 3 is 1. 3 to the negative first is going to be 1 over 3. 3 to the negative second is 1 over 9. 3 to the negative third is 1 over 27. Notice the number on the bottom, the denominator, is the same thing as 3 to the first. 9 is the same thing as 3 to the second. 27 is the same thing as 3 to the third. So there is a pattern here. Okay, and we'll talk about that on the next problem. 4 to the fourth, 4 times 4 times 4 times 4 is 256. Okay. 4 to the third is 64. 4 to the second is 16. 4 to the first is 4. Notice dividing by 4. If you don't believe me, check your calculator. Okay, 4 to the 0. Well, if you think about what the last one is, 4 to the 0, divide the previous number by 4, you would get 1. 4 to the 0, or 4 to the negative first, excuse me, would be 1 over 4. 4 to the negative second would be 1 over 16. 4 to the negative third would be 1 over 64. Notice 4 on the bottom is the same thing as 4 to the first. 16 on the bottom is the same thing as 4 to the second. 64 on the bottom is the same thing as 4 to the third. So what happens is if you have negative exponents, what you do is you move it to the opposite side of the fraction bar. So 4 to the negative first, what I did was I took 4, moved it to the bottom of the fraction, and made the exponent a positive. 4 to the first on the bottom. 16, 4 to the second. I took the 4 to the negative second, moved it to the other side of the fraction, to the bottom, and changed the exponent to positive. 64 is 4 to the third power. So these are all 1 over those. Okay? So let's look at this one. 5 times 5 times 5 times 5 is 625. 125, 25, 5. And then you get 5 to the 0 would be 1. 5 to the negative first would be 1 over, move 5 to the bottom, to the first power would be 5 to the first. 5 to the negative second would be 1 over 5 squared, which would be 25. 5 to the negative third would be 1 over 5 to the third, which is 125. So, based on your description in problem 23, simplify 23 to the 1/3 power. Well, what I would do is I would make a fraction here. What I'm going to do is anything with a negative exponent moves to the other side of the fraction bar. So what happens is 23 moves to the bottom of the fraction bar with an exponent of 1. There has to be a number on top, so it becomes 1 over 23 to the first power, or just 1 over 23. Okay, look at this one. Evaluate 8 to the negative second. Well, that would become 1 over 8 to the second power, or 1 over 8 times 8, which is 64. Again, that negative exponent, we make it a fraction, we move it to the bottom. Okay. And then if we look at the next one, okay, evaluate 6 to the negative third. Make that a fraction, move this exponent to the bottom would be 1 over 6 to the third power. If you don't know what 1 over 6 to the third power is, use your calculator. 1 over 216. So what do we do with negative exponents? We move it to the other side of the fraction bar. That's the rule. What is a 0 exponent? So if I had 5 to the 0 power, that is going to be the number 1. If I had x to the 0 power, that's going to be the number 1. If I had 125 to the 0 power, I would have the number 1. Any exponent of a 0, so any number raised to a 0 power, is going to be the number 1. If I had x to the negative second, negative exponents mean move it to the other side of the fraction. Every number is a fraction, so what I would do is I'd take this x to the negative second, move it to the bottom. So it'd be 1 over x to the second power.